Am I audible to you?
Yes, sir, we can hear you.
Okay, thank you, Ramesh. And as you have gone through the discussions in management information systems, you should have gone through 4 different discussions, I believe. And we have met Professor Dushanta Kulatunga in the previous discussions. And today onwards, I'm going to step into the discussion. And I'm Mahesh Fernando, attached to the Department of Information Technology. Some of you might have met me at the interview, but for those who have not met me at the interview, and uh, welcome to the discussion. And what I do is I'll share the screen and uh, take you through the discussion. And if there is anything important, and we can have a kind of interactive discussions. And I always believe that you can easily give more inputs to the discussion and take the discussion through with a not in a way that I'm delivering everything and you are listening to me and just getting through with it, but to have some interactive discussions are always welcome. What I do is I'll share the screen and go through the discussion, and I'll try my best to take some of the breakout room discussions in the sessions to come and make it more interactive. But we know that we cannot physically meet each other in the way that we have done in the previous years. But we'll try our best to make it more interactive and have it kind of a feeling that in the classroom. So what I expect from you is to join in the discussions when and where it needed, and give your inputs to the discussion, because this subject is a multidisciplinary subject. You might be come from any of the domains that you are expert in, but here we are learning some of the things related to the information systems. And I believe many people are here, those who are still, those who are at the moment working in IT department, and there might be some more people, those who are not in IT but in different other domains in the organization. But not as in undergraduate courses. In postgraduate courses, what we always expect a kind of a learned interactions. Therefore, I'll be always the facilitator and give you the chance to give more or share more of the experience you have with the classroom, right? Therefore, uh, in the discussions in the future, I'll take you into the discussion and please join in the discussions rather than being say mute yourself, but keep your microphone muted in other times. But when and where a question comes, so if I ask a question, please join in the discussion and interact with this, because the time that you are spending here is not for the purpose of just listening and taking down notes. But the main point is you have to learn the subject and to understand what we are discussed. And some of the times that we have experienced, even some of you have experience and knowledge in the area, some of the things need to be updated, and some of the things need to be shared with other people also. And what we always believe is that that sort of a sharing is important for our postgraduate students. Otherwise, as a kind of a dealing with many people, MBA might have some different meaning. The name or the characters comes after your name, after you get the degree, should be meaningful, right? So what you always expect, that sort of a professional interference from you, and have the discussions into the many things to come. All right. And we have 30 people join at the moment. What I do is I'll just give what a kind of a brief, not like a brief, but basically idea what you have done and why today's discussion is important. And I'd like to take you through that point from that point onwards to my discussions. Let me share the screen and show you the course outline which you have gone through, must have gone through by now, and show you why we are starting this discussion today. All right. Let me stop my video and share the screen because it will delay the things sometime. I believe you can see the course outline.
Yes, sir, we can see.
Okay, right. You are in the subject of MIS, or Management Information Systems, MMS 5303. And I'm not going to go through this description because I know that in the first day you have get some idea about this and the learning outcomes. And from the first day, you should have gone through fundamentals of information systems in business and basically identifying these things related to the competing with information technology, right? And competing with information technology goes into the discussions of electronic business and systems, because e-business is a kind of a information system which you can understand in a way with all these components that we have discussed here in these earlier discussions, right? Just to make you into the point, just to take you to the point where we should understand the things related to the today's discussion, which is data resource management. You should have different components in information systems. Can I have some idea about the components which you have learned about the information system? Yeah, I'm going to go through the recording for my session, and this is a kind of a pre-preparation to the discussion. Other than just stepping into the discussion, I'll like to do this because I need to have some idea whether you have clearly understood the area, right? So I'm going to go to the recording with my discussion, right? Can you have some ideas? What are the components which you have understood in an information system? Anybody? What are the components we discussed? You should have discussed about the information systems, and you should have discussed about the computer-based information systems and manual information systems. What are those? And otherwise it's called as CBIS, computer-based information systems. In a computer-based information systems, what are the components which you have understood? Anybody? How can we divide the computer-based information systems into different parts? Somebody who remember, if it is a computer-based, a computer is a tool there, right? Then if it is if the computer is a tool, what are the parts that you discuss basically in a computer system? We can simply divide the computer system into 4 different parts. If I make it somewhat easier for you. One is the hardware. Other one?
Software.
Yes, correctly. Software. Software is another thing, because hardware is like a car, and software is like a driver that drive the car, right? Hardware and the software. Apart from that,
liveware.
Yeah, we take the liveware into the discussions with the information systems only, but not with the computer system. That's good. We can consider it as a component. Liveware on the, otherwise we can call it as a people or the users, right? Now if I put yourself into the identification of the components of a computer system, because computer is a tool that we are using in information system. Therefore, hardware is the one thing, software is the other thing. We'll keep a liveware aside for a second and try to understand a computer system first, then go into the information system. Hardware, software. Any other important component?
The database.
Yes, database. So we commonly identified as data technologies or data storage technologies, right? Because there are a lot of things, right? The data management technologies, if I put it in that way, right? Hardware, software, data management technologies. Any other? How we communicate?
Network.
Network or the telecommunication, right? So if I think about the information system and identify major components of a computer-related items or computer-related things, if I name them as a information technology infrastructure, right? Remember those terms which are helpful to you. If I put it as a information technology infrastructures, these four things are the four pillars of an information system, right? Hardware, you can take some notes if you like. And because this is the kind of a pre-preparation which you should have this knowledge before we going to start the discussion today. Hardware, software, telecommunication, and data management technologies. So telecommunication technologies and data management technologies. So those four things, we call it as four pillars of an information system, or four pillars of an information system, or in other words, information technology infrastructure, right? So if it is an information technology infrastructure, and on top of the platform which created by these four different pillars, right? It's like four corners, and we are preparing the platform on top of it, right? It's like a building, right? On top of it, that's the platform we are creating for our information system, right? Then if you have that platform, on top of that platform, we need to build the information system. That's the point that we are differentiate information system from a computer system, right? So those four things are computer system components. And there will be another things we'll add to this discussion. You should have identified about the different resources and said that in the resources, one of the another resource is people or the user, right? That sometimes people call it as a liveware. The liveware will not come as a part of a computer system because computer can be used by anybody. If I take a computer, if I assemble a computer, that computer can be used by anybody. But information system is not allowed to use by anybody. Information system allowed to use by only by the users. If you have a kind of authentication to log into the system only, you have become a user, right? So the people or the liveware will be another component of an information system. So you should have learned about that 5 things as resources, and including that, you should have learned there is something known as a procedures or rules and regulations. Because every time while you are working with an information system, that procedures should have a role to play, right? Should have a role to play. So once you think about the information system, those 4 pillars, hardware, software, data technologies, telecommunication technologies, people or the liveware, plus the procedures will come into the discussions of an information system. If you name any information system, all these 6 things are there. You can simply identify those 6 things in any information system that you name. Think about the organization, and you can simply differentiate those 6 things in your organization. If you think of a ATM system, for example, ATM system have hardware, ATM system runs with the software, right? There will be a data technologies which store the information about the customers, and there will be a telecommunication technologies which share the information between the head office or the branches to the ATM machine, right? And there will be people like you and me as users or the customers of the bank can access to the banking system. Plus, there are procedures or rules for the customers. If I'm a user, I should have a PIN number, I should have a identification number or something like either my card or a bank account number should be there to access to the system. Right? That's a one rule. And in withdrawing money, there might be some rules. Bank might be says you are not allowed to withdraw more than 100,000 in a given day. Likewise, there will be some procedures in an information system, right? Therefore, once you think of these 6 different things, or in other words, if I look from the point of our resources, 5 different resources which we have discussed in the foundations of information system in the first chapter, one of the important thing there is data technologies. Therefore, today we are going mainly concentrate about the data technologies because data is the heart of a system. If there's no databases, there's no data storage, there's nothing there in the system, right? You can have the interfaces, you can have all the other things to communicate data and share the information, but if the database or the data is not there, it's like a human without a heart, right? So we are discussing about data technologies or databases, data resource management today, with that identification, because data resource management is one of the important components of an information system, or basically a computer-based information system, right? That need to be very clear to you before we're going to start the discussion for today. And with that, we can start the discussion for today, because we are not going to discuss about other components, because hardware, software, telecommunication, we are not going to touch. Those are sometimes having a lot of say technical things to there. It will not suit for MBA, but for a MBA, data or data management identification is very, very important, because you might be belongs to any domain in your organization. You have to work with information system, and you should have some idea about data and the information in your organization, right? If our discussion goes into the data management because of that reason, right? Shall I share the screen for today and start the discussion for today with that identification? Right? This is the today's discussion, data resource management. From the discussion that from the previous discussion that we had, anything to clarify? Anything to any unclear area to you?
Excuse me, sir.
Yes, Hastad.
Yes, sir. Could you start the recording?
Yeah. I'm going to start recording now.
Yes, thank you.
Okay. Right. Then shall we go into the data resource management, and let me start the recording and record these things.
Recording in progress.
Okay, then good day to you all those who joined with the data resource management, right? And with this discussion, we mainly concentrate, as I explained to you, is about the data resources in an information system, where we are discussing about the management of data in an information system. As you have understood by now, the data or data management is very important, as it's like a heart of a human. In an information system, the heart is the database. But we need to have some idea apart from other different components. As I just explained to you, the hardware, software, telecommunication, and data technologies, and people and the procedures. The data is a prime resource which we need to understand and work with, right? In order to start our discussion, I like to have some questions and make you aware about this some misconceptions related to this, right? Let me
Recording stopped.
pause the recording for a second and ask this question and make your answers, right? Like this is one scenario which I like. This might be not there in your slide. That's why I just stop the recording, because we need to have discussions on this. Scenario one: you meet someone in the computer store as a knowledgeable IT professional. You want to help this person. He says he's looking for a database software to keep the names and address of his customers, to do his mailing and billing, right? What does he really need, right? What do you think? Is this person really need a database software to do this? What he need to have a names and address of a customer to do his mailing and billing. He need to send mails and prepare the bills. Does the person need a database software, or is there any easy method? Somebody who are aware about this sort of a situation? What I need is I have a set of names, I have the addresses, and I need to send emails or mails to those people and kind of prepare a kind of a list and manage that list.
So can you use Excel?
Yes, Excel is a one thing. Excel in the sense, what you can do is in Microsoft Suite, you have a very easy mechanism of what there's a in Word or document management. There's a concept where we can easily combine list of data and prepare a letter or something which might be propagate many times with different information. There's a concept in Word or document management. What is that?
Mail merge?
Mail merge, exactly. Right? Therefore, he really needs a mail merge program. He does not need a database software because database software is a burden. Sometimes it's a more weight that to put it into a computer. Right? There were some of the might have idea even to keep something like this, even to do something like this, they go into the databases which is not needed. Right? Good. There's another scenario. What do you think about this? You call your travel agent to make your airline reservation for the vacation you have been waiting for all years. The agent responds by saying that she cannot do that just now because the database is down. That's a very, very common answer people give. What does she really mean? The database is down, or is that really database down, or some other thing? Some people say that if the system is not working, they say that database is down, right? Because it might have a feeling that people will not question that. So it might, what does she really mean might be this.
Maybe network issue.
Yeah, it might be network issue, or it might be a reservation system altogether is not working, right? So we don't know actually what is happening. Is that they're in the database or network or a system altogether? But as we have understood the components of an information system, if one of the system components is not working, mean that the whole system is not working. So we cannot simply say that it's on the database, right? So that might be another thing. People might be simply put it into the account of a database once other things are not running or not working properly. All right. The third and the last scenario. You call your cellular phone company to complain about on latest billing statement. The phone company representative says that the database must have printed some incorrect numbers. What does the representative really imply? Is the database printing something? Can the database print something?
No.
No. Yes. The database cannot print something, but it really might have happened.
Data entry error.
Yeah, it might be a data entry error, or there might be some miscalculations in the system, right? The representative really implies that the billing application miscalculated the charges, or sometimes it might be a data entry error, would be the reason, right? It is not with the problem of a database, because why? We know that database is like a storage, right? And if I put garbage in, it will put garbage out, right? That we commonly identified that as acronym GIGO. What does GIGO mean? If the garbage in, garbage will take out, or garbage will put out, right? The database is not responsible for that. The database is a storage where we work, right? So with that, I believe these are some of the misconceptions people having about the databases, sometimes without really knowing about the components and the work of the components in an information system. So usually, the information work as a kind of a architecture where it can work in 3 different tiers, right? 3-tier architecture you might have heard of, right? Sometime you might, or some people might, those who are in IT and IS might have idea that there will be a backend, right? There will be a backend and there will be a front end or the user interface, UI, right? This is the backend database, right? And in between, there are some applications running where, right? Applications are running where we can work with the data, right? If the user is here, the application work with the data, and this three areas. This is the front end, right? This is the front end, and this is the back end, and this is the middle. So this three-tier architecture work in a situation where we work with the information system, right? Later on, we're going to go into more detail about this sort of a situation. But simple idea of an information system, it's like this. You should have a data storage at the back end. In your back office, there might be having a lot of data storages, and you are working with applications where you can see the user interface here. Everything that you do it from there, and you might not have idea about the applications and databases if you are a non-IT person, right? But simple idea behind this is you should have some sort of a situation in more complex application. This work in different ways in different situations, all right? With that idea, I will go into the learning objectives.
Recording in
Right.
progress.
Our learning objectives are these. At the end of this discussion, we are going to discuss about these things and have some idea about these different areas. We're going to explain the business value of implementing data resources and the management and the process, as well as the technologies in an organization, right? Mainly the business value of implementing the data resource management process, right? Because we need to have idea about the business value. Since you are in MBA, you should have idea about business value regardless of the domain. That line the advantages of a database management approach to manage the data resources of a business and compare with the file processing approach. There are two different approaches you should learn, and you're going to understand about the data management approach and file processing approach. Two different approaches where we can work with. And to explain the steps of a database design process, you're going to have some idea about the database design process. Even though you might not be attached to the IT department or IT division, you're expert in your area. You might be in the marketing, you might be in HR, or you might be in any functional area in your organization. Some point of a time, you might be invited to explain your domain expertise to the people, those who are design and develop databases. In that point, you need to have idea what is the database design process. For that reason, we are learning about database design process in our discussion. And also, we're going to have some explanation about database management software and how it helps business professionals and to support the operations and management of a business. So our discussion ends with the idea how the data can be identified in organization and what sort of facilities could be available by data technologies to database technologies. What are the different type of databases, as well as how the concept of big data and data mining concept could be taken to organization to different levels of competitiveness, right? So this is the main focus areas of our discussions. You can see that some of the letters that I have made different color, which gives you a kind of a focus discussion for those areas, right? And with this, I like to have some questions, right? And I believe that with this idea, you should have answers for these questions. Shall we go into this? Why data resource must be organized and structured in some logical manner? You should have learned that. You should have some idea why you, since you are working in an organization, database, the term database might not alien to you, very familiar to you, right? And you should know that data is stored in a way, in a logical manner. Why these organizations expected to have this data in a logical manner? For what reason? Any reason that you can take up?
To ability to convert to information easily.
Yes, in a way, because if it is a mess which you cannot convert that system or that information, that data into the information, because the data is processed, and after the processing of data, we identified that data as the information, right? That's the one thing. Good. Any other?
We take the decision.
Yes, one thing. Take the decision. I heard the one said that decision. Yeah, for a decision making. Yes, good. And have you heard about the term called rational decisions? What do you mean by a rational decision and usual type of a decision? Rational mean? There's a logic behind that. Every time we are thinking about the pros and cons of consequences of that decision. So we are not taking decisions from the feelings or from the idea that just come to a mind. We are taking decisions with evidences, right? The rational decision means you are taking decisions with evidences. Sometimes your decision making is not merely happen with your experience. Your decision making happen with the experience plus some data that you had earlier, and with the analysis of data, you come up into a conclusion and take the decision based on that data. So we call it as a rational decision making. So if you have a kind of organized data, it will be helpful for rational decision making. That's good. Any more? Yes. Why they might be organized in a logical manner? What we really do with the data in a database, we put the data, we manage the data, and we get out the data. Yes.
To facilitate it, retrieve the data.
Yeah, very important. Retrieving the data. The data is here and there everywhere, but the retrieval is difficult, right? It takes time. We can put the query, we can put the question to the system. The system will take a lot of time to find the exact information and take up into the screen or the user interface. If it is mixed up in a manner where it cannot identify by the system. So retrieval is difficult if it's not logically arranged in a way. That's good. Any more?
To store.
Yes. To store in a way that we can do it in a way. Think of a situation, your storeroom, you put things here and there, and if there's no kind of a labeling, right, no arrangement, and it will be very difficult. If I am going to store a new data, we don't know where to put that, right? If it is logically arranged, it will be easy for us to store it in a logical manner where it can be retrieved again in a very easy manner. Yes, any other thing?
Data analyze.
Yeah, to analyze the data, right? The analyze the data will most of the time data analysis is a difficult thing if you are not arrange it in a proper way, right? We can call it as analysis of processing, right? Process, because process the data. We collect the data, we process the data, or we disseminate data in a system. So if processing data or analyzing data will be difficult if you are not manage them in proper way, right? Likewise, these are some of the things which you can identify for the reason, right? We can access easily if it is logically managed. We can process efficiently, analyze or process efficiently, and we can retrieve quickly. It will be not retrievable if it is not arranged in a order and managed efficiently, right? We need to manage the data, right? Manage in the sense we can take decisions, we can arrange in an order where we can clearly see things. Sometimes we can convert the data and display it like a graphs, right, rather than tables, right? Likewise, indifferently, we might be need to concentrate about accessing, right, processing, retrieving, and managing the data. We always work with the information system to do these activities. So this answer is not there in your slide. I just want to make it more clear to you and make it kind of interaction. That's why I have not put the answer, because this answer is basically the answer that you can take with a lot of other information, right? Got the idea? Then what about this question? Why do business professionals must understand how data are structured, stored, and accessed? Why you should understand? Any reason? Is it a job of IT people only? Surely not. Nowadays, you work with data regardless of your job. You work with a lot of data. Then why? Yes,
Data,
Ramesh. Yes, Ramesh.
data asset for the company, and my decisions are taken using data-driven approaches.
Mm-hmm.
For the
Yes.
professionals, it is an asset. I mean,
Mm.
business point of view.
Yeah. Okay. Yes. The professional is like I said from the business point of view. Good. Yes. Any other?
All the managers are taking decisions, not only IT people.
Yes, exactly. Because it's like a work of everybody. You need to have idea, because if you take all of you, if you take yourself as a professional, and you everybody might collect the data, but you are using the data. So you should have idea what the data do and what are the data available in the organization, right? So the business professionals need to understand. They will not compared to the earlier time. Nowadays, everybody are working with the data. So you should have idea what is the data that we have in our organization, and how can we retrieve the data, and what are the ways that we can use the data, for what purpose that we are using the data, right? So once we think of this question, uh, we can simply identify this as the answer. They can gain greater strategic value from their organization's data resources, right? The strategic value, I believe that you should have discussed about the strategic value or competitive advantage in the previous discussions in MIS. The strategic value is one of the important things that you have to achieve. Without data nowadays, it's very difficult. You cannot, there are different, strategies people use to take competitive advantage, right? But nowadays, it's a very, very important, because as we all know that we are living in a lot of data, or different type of data, or heterogeneous data, we use that term, and that we called as a big data. But we work regardless of your profession, regardless of your domain that you're expert in. We work with how we can take strategic advantage or strategic value and competitive advantage over other competitors with the data. But simply, we can understand that it's not the only responsible person, or the IT people is not the only responsible people for data. Nowadays, everybody should know about the data, right? These are some of the thought-provoking questions which I put it into the discussion, and we should have this idea also. Fundamental concepts of databases. If I equate it with the writing that we have, or kind of a documentation, we can simply differentiate. We can simply divide the documentation starting from the most minute point, where is the character or the letter, right? We know that if I think of the document, Document is a collection of paragraphs, right? The paragraph is a collection of sentences. Sentence is a collection of words. Word is a collection of letters, right? You know that in this sort of a division, we can think about the databases from a layman point of view. How can you organize data logically in this equivalent terms? What about the letters equivalent to a databases? Concepts that you can equate. Letters equivalent to in database environment. What's the most minute part in a data? Yes, any idea? Most minute part in the data, in your store in the data?
Is it database?
No, most minute part. Database could be equivalent to a document if I put it to make it easy. Most minute part, smallest part in the database. You can talk, no worries that I can see that some of the people are sending chat messages. 1 and 0. 1 and 0 is a bit. Bit is not the answer. If I think about this differentiation, it's like a letter. If I like to have a letter, what is the term that we are using in database terms? Anybody who aware? Those who are not aware, it's something to learn. I'm asking for, yes.
1 and zeros.
1 and 0 is the bit. If I think that it's a binary, right? But going beyond that, if I think of 8 bits, what do you call it? 8 bits equivalent to a
Byte.
1 byte, yes. But in case of a data management, we are using the term not the byte, but character, right? It's a character. So once you think of a database environment or database concepts, equivalent to a letter in a document, if I think of this sentence, right? W is a 1 character, R is a 1 character, but W is developed with different byte, right? So it's a 1 byte, but it different bits, right? When in computing, 1 and 0 will be representing a bit, collection of bit or 8 bits. We identified as a 1 byte. Therefore, W letter or a character is developed by 8 bits. So we are not going to that level of bit, but we are referring to this as a character in a database. If I am storing this word in my database, I need to store W, R, I, likewise, all these as separate characters in my database, right? So this character could be in a database environment, could be a single alphabetic character, something like this, right? Uppercase A to Z or lowercase A to Z, right? All these are alphabetic characters or numeric 0 to 9, right? Or other symbols. It might be a hash sign, it might be dollar sign, percentage sign, ampersand sign. Likewise, symbols are there, right? So in a database, we are storing characters. It might be a character or a letter, something like this, or a number or a symbol. We are storing as most minute part. The collection of characters, how we call collection of letters, we call it as a word, right? The WRITING is a collection of letters. We call this as a word. In database terms, collection of characters, how we call it? Any term, any wording that we are using? Those who are aware about this? Yes, collection of characters in database terms. Anybody? Collection of characters we are storing, for example, a name. Yeah, Purnima.
Strings.
A string, or in other way, we call it as it could be a field, not a string. Because if it is a string mean, some people call it as string, it's only for a alphabetical collection of characters, but we use the term field, right? It might be a collection of alphabetical characters, it might be a collection of numbers, it might be a date, or it might be symbols, right? We use the term field, which is equivalent to a word in a document, right? I'm referring character is equivalent to a letter, word is equivalent to a field, where different characters could be a field, right? For example, if I am keeping this information about customers, customer name field might contain lot of characters for customer name, customer address, customer contact number. Likewise, field is a term that we are using in database discussions, right? So we sometimes call it as it's an attribute of an entity, right? Attribute of an entity. Entity could be a object, entity could be a person, entity could be a place, entity could be an event, right? So if I am referring to a product database, the product is an object, right? If I am having a product, the product can be explained, right? Product features can be explained by the attributes of the product. If I have a product, and product should have a product code, product name, expiry date, manufacturer, likewise different attributes might be there to explain the product. Likewise, the field can contain that sort of attributes, right? So if I am thinking about a database environment, collection of characters, we call it as a field. Field could be a character field, which you called as a string, which can store strings, right? The field could be a date field, which you can store the date of birth, right? Date of hired person or date of expiry, right? A field could be a number, such as a salary of a person, right? Or a price of a product. Likewise, the field could be any type of a character collection, right? That's the equivalent to the word. Now, what is the equivalent term for sentence in a database? Anybody? Now you should know the pattern that I'm explaining this. Now, if the collection of fields, how can I name it? Anybody who aware about this?
Record?
Yes, exactly. Record. Those who are not aware, you can have idea about this record. We call this as a record. If I put it in this way, I'll because this is something that we are discussing later, but simple idea. If I have a list of information as a table or in a file, right? And if I have this sort of a table to explain the information or to store the information, right? I might have employee information, EMP number, right? EMP number might be a one field, employee name might be a one field, name might be another field, right? Address might be another field, and salary might be another field, right? If I think of this 1111 is the employee field, employee number field might be Nimal, right? Address Colombo 7, salary 200,000, right? Likewise, if I think of this sort of information list, we call that as a record in our discussions in databases, record, right? So if I think this as this is a one character, right? Collection of characters is a field, employee number field, employee name field, address field, salary field, right? If I collection of fields together, this is a record, The record could be a variable of fixed length. For example, employee number having the 4 digits, that's a fixed length. What about the name? Name could have variable length, right? Name could have variable length because name from person to person is different characters, different number of characters. So it's a variable length field, right? And it might have, sometimes we call it as a single instance of an entity. So this is the, if this is the employee information, this is a single instance. We are using the term instance, right? And it contains unique identifier, something like we call it as it's a primary key. Later on, we can have some idea about this. This is the primary key, right? We call this as the primary key, PK, primary key, because this one will always unique. If I have another employee information, might be 2222, right? And another name, likewise, you can fill this information, because this will be a unique code which can identify whole record, right? So by that way, we can simply identify a record is a collection of fields. These are the fields, right? Now this is equivalent to a, we have letters equivalent to a character, words equivalent to a field, right? Sentences equivalent to a record. This is a record. Now collection of records, something like this. How can we call it in database environment, which is equivalent to a paragraph? Anybody? Collection of records. Here I have 2 records. Likewise, if I have 100 records all together, what we call in a database environment? Anybody?
File.
Sorry? Yes, tell it again.
A file.
Yes, file. Good. It's a file, right? We call it as a file because the file always have these sort of a fields and its collection of records, right? The file will be always sometime call it as a table, sometime something like this, or some people call it as a flat file. They are using the term flat file. If it is something like the flat file, right? Later on, we are going to discuss about the relationship with files. But if there's no relationship, we just see a file as this, right? If it is only a one file where there might be many records and it maintained separately, right? We call that as a flat file or a table, right? Or a table, right? And all the time that it might be contain rows and columns. You can see the rows and columns, same as in Excel sheet, rows and columns. And it might be that rows and columns are in a tabular manner. This is a tabular manner, tabular formation, and could have different formations, right? Could have different formations. Sometimes we can identify the files from the perspective of applications, right? Sometimes we say that it's a payroll file, the inventory file, because we can differentiate, we can view from the application perspective. You know that there are payroll applications, there are inventory control system applications. If I see the files from this sort of a application perspective, we can call it as payroll file, inventory file, customer file, right? Likewise that way. Or in other words, we can identify from the perspective of the data or type of data. We can have files as the document file. We can have the files as the graphical image files, right? Or sound wave files. Likewise, based on the content of the data of that file, we can identify those files, right? Or else, we can identify the files from the permanence. What do you mean by permanence, right? Sometimes you might have an inventory control file, so transaction file in your organization. The transaction file is always maintained in the day-to-day transaction. So sometimes weekly transaction you might be keeping, right? And weekly transactions might not going to keep for another week. At the end of the week, you might be convert that into a master file, right? Or you might be convert that might be there as into a backup file, or you might be put it into a history file or a archival storages, So based on the permanence, how much time that you are keeping that file, the file could be differentiated and file could be identified, right? So once you think of the collection of record as such, we can call that as a file or a flat file in the sense, or a table, or in a tabular manner where you can have columns and rows, and it can be identified from the application perspective, from the type of data perspective, or the permanence perspective. We can identify files, right? Now we have reached to the paragraph. Now what's the collection of paragraphs? We call it as a document. A collection of tables, how we call it? Collection of tables? Yes. How can we call it collection of tables? Yeah. We are in the discussion now. What is the discussion? We are in the discussion now.
Database.
Database, yes. Now I believe that you are clear about this situation of comparison. I am compared the letter with the character. I have compared the word with the field. I have compared sentence with the record. And I have compared paragraph with the file. And I have compared the total document as a database. Which means that if I have this sort of a table collection, and that collection could be combine each other, or these tables could be link each other with the relationship, later on we're going to discuss, we call that as a database or data repository. Sometimes we use that term data repository, right? Independent of application programs which can be used them, we are talking about this, right? We are talking about this from a point of a independent data storage. With the application, it becomes an information system because as I showed you earlier, here in the discussion, I have identified it as the back end is there always that it can work with the information system. Therefore, once we are dealing with information systems, we mainly concentrate about the information system, and the information systems, we can say that these databases are become the back end in information systems most of the time, right? So this is a simple idea you should have in order to go with the discussion, and you should know these terms because they are using these terms in the future even. Then these terms should not be alien to you. If I say the character, if I say the field, record, file, and databases, you should know this relationship and how it works with this situation. Suppose database is usually we are identifying in a storage. If I think about the database, it's like we can have later on we are identifying a relational database, right? If I have this sort of a table like, right, this sort of a table, later on we'll identify this as the relational database where we can see these files are linking each other, right? These files are linking each other where all these information could be together, right? Work as a database, right? So that's the idea you should have about the databases. Then these terms should know. That's why in the fundamental concepts we discussed about this. I believe that is clear to you and what we are doing. And this is a kind of an example of a arrangement. You can see this is the file, payroll file and benefit file, and human resource database. You can see the content of two files, and these are the fields: name field, social security number field, salary field, right? And these are the characters here. These are the characters, and this is the record, the one record, and you can see two files, and these are employee record 1, employee record 2. Likewise, you can have many number of employee records in the employee file, and you can have benefit file also there in similar manner, where we can think of collection of tables or collection of files could be simply identified as a database, right? Clear? I believe this might be not a new thing for the people, those who have learned databases, who have some idea about databases. But for the people those who are not familiar with the database discussions, that terms need to be there in your memory now. The field, record, and these discussions with characters should have there in your mind. Some people might be called that as a record, or some people might be called it as a tuple. Another name for record is tuple. Right? Tuple is another term. Likewise, in databases, we have different terms. And database structures, we have different database structures which we are usually identified, and the relationship among the many individual data elements stored in a database are based on a logical data structure, or sometimes we call it as models. Right? We know that data could be there in different formation, and in a database, the models that we are identified in the way where the data could be combined together in a database. This is the common database structures. We can have a hierarchical, we can have a network, we can have relational, object-oriented, and multi-dimensional database models could be there, or data models could be there, right? We'll see what is the simple idea, because it's very simple to understand. Only the structure, only the way that data link each other use this name. What is hierarchical? Right? Hierarchical is something like this. You can see that it's like a upside down tree. You have the department. The department maintain two projects, project A and project B. Project A having employee 1 and employee 2. If I am keeping data in this sort of a hierarchical manner, we call it as a hierarchical structure. Right? So it's implied from the name itself. And this is the network structure. See the difference? If I have a department A and department B, employee A, employee 1 and employee 2, employee 3 is there. Department A, employee 1 and employee 2 is working. Employee 3 is working in department B. Project A is having employee 1, employee 2 and employee 3 working in the project A. Project B having employee 1 and employee 3 is working. So if I am linking these sort of information together in such a situation, like a mesh, we call that as a database is like with the network structure, right? It's a network structure, right? So with this hierarchical structure and network structure was the two different structures which were started earlier in developing databases. Therefore, there are databases some time back people used as hierarchical databases and as well as network databases, right? Sometimes the USA more landing projects, they have state to have used hierarchical databases earlier, but as well as network databases to maintain the data they are working with. But later on, they have understood that working with this hierarchical and network structure is very cumbersome, very difficult. So people move on to a different structure which are still working with the relational structure, right? There were almost all the databases, not all, but some of the people now going for an unrelational also. Most of the databases, huge databases nowadays, they are keeping as relational structure. The relational structure was introduced with a concept in mathematics. Anybody know that concept? And the concept in mathematics we are learning in grade 6, 7 is based. Yes, sorry.
Is it relationship?
Yes, relationship. But there's a mathematical concepts we are using for base of this, or a base of this relational database. What's the mathematical concept? The theory. Yes, sorry. Sorry.
Axioms.
Axioms
Sets.
comes later. It sets. Good. It sets. In singular, we call it as a Pulaka. At what age that we are learning Pulaka? Sets. It might be grade 6 or grade 7, no? Right? It sets. Or set theory. Set theory is the base of this sort of a relationship. It's like, because everything is like a set, and a part of it is identified as a subset. Pulaka and Upapulaka. Got it? So if it is a set, if I am identify this as a set, right? I have an employee number, employee name, employee title, salary, department number. Likewise, we have a set. And if I take a part of this, it's like a subset, right? The sets could be joined with another set, right? So here in the concept of sets, sometime back, a person named Professor E.F. Codd, you might be heard of that name. Professor E.F. Codd introduced with a seminal research paper, he said that rather than using hierarchical and network methods in arranging data, you could have used the set theory and use the relationship with relational structures, right? From that point onwards, people are starting to use these relational databases around 1970. Could you imagine? Still we are using this structure because it's very, very easier and very, very convenient rather than using relational or a hierarchical structures, right? In this structure, we have these things, right? Data elements are stored in a tables, right? Data elements are stored in a table. Likewise, this you can see the tables. I have two tables here: employee table and department table. Row represent the record, and column is the field. You know what is a record and field now. So this is a record, and this is the field: department number field, department name field, department location, department manager. Likewise, these are the fields. And rows are different records or tuples, right? Can relate data in one file with the data in another, right? You can see that department number is a one field where I can have the same information somewhere here in a different table or different file. Because why? If I have the employee number, right? Employee number is the person of a number of an employee, and name, title, salary, and the department. Without keeping all the information about the department in the same file, I can have a separate file for a department information, right? So with this relationship here, it's a relationship. It can simply create this relationship where it can easily read the information about this person, right? So department A, if I need to know about the department A, I can simply jump into this table and read the department information. By that way, what they have done, rather than repeating the same information again and again in this table, the repetition of information is now reduced by keeping a separate table, right? In order to do that, we need to have this sort of a relationship, right? In this case, we name this as the primary key. Remember the term that I use, PK, department number primary key, and employee number is the primary key of the employee table, primary key, right? And this one is a primary key of a different table appearing in here in this table. This came from a foreign table, and because of that reason, this column we identified as what key? We identified this as a
primary key. Yeah.
What the term that we are using for this key, this column? It's yeah. What is that? This column is FK. What is FK?
Foreign key.
Foreign key, right? Foreign key. It's a foreign key. It's taken from a different location. So can you see that this department A appearing many times? Department B could be appearing many times, but in this table, department A appear only once because primary key cannot be duplicated, right? So in case of identifying these two tables, now tell me somebody, department table and employee table, which one is the parent table, which one is the child table? Any idea? Based on this identification, we identify who's the parent and who's the child. There might be many. Yes, parent?
Parent is a department table.
Yes, this is the parent table.
Because of primary key, is it?
Yes, because of primary key in the sense this primary key will not going to repeat again, right? Which means there will be a one parent. Think of it as a mother. There will be a one mother and there might be many child for that mother. So this will be a parent table and employee table will be a child table, right? Child table, because I have many different department appearance here in this table, and once we are recruiting an employee, that employee could be put it into a different department. That department name again could be appear several different times. Your parent table contain department A once. Department A could be appearing many times in the child table. Because of that reason, in this relationship, we can simply identify parent table as department and child table as employee table. Right? That's a bit of things that we should know about relational structure, relational databases, right? And relational databases or relational structure, it's a common structure as we said that, but nowadays we have non-relational structures also. Later on I'll go to that discussion, but simple idea till this point is this. So we are storing information in all the places that in organizations, in a bank, and most of the places as relational structure, right? And in the relational structure, we can do some different things. Just see what are these. We can do these things. What are these? We can select the information with the relational structure. We call them as three basic operations, right? We can select or create subset of records that meet the standard criteria. For example, if I have an employee table, I can query employee earning more than $30,000 display to me. So what I do, I'm selecting information. Can you see this purple color records? I'm selecting, assume that this purple color record are the people, those who having more than 30,000 as their salary. Then I'm selecting these people from the record. Therefore, selection is a one operation that we do with the relational databases. And also we could do something known as joining, combining two or more tables temporarily, right? Look like a one big table. The same example which I have taken earlier. If I have employee table and a data department table, I could read the employee table and jump into the department table and read along with the line and get more information about that employee. The same way, joining could be used to join two different tables. So joining is another important operation in a relational database. Projecting is another operation. The projecting, what we do, we are not selecting every record, every field in the record. We are selecting specific records, specific fields, not the record, specific fields. For example, if I have an employee information, if I am a top level manager, I like to see the employee salaries. If I am taking employee name as a one field, this might be employee name field, this might be the salary field, right? He like to see the employee name and the salary only. Other information is not needed at this moment. So what I'm doing projection, right? I can do the projection. I can project in the sense I'm retrieving different fields in my table, not all the records. All the fields in the records, I'm selecting only the specific fields, right? Likewise, these three operations are there in databases. Later on, we'll see about this, about the database operations, right? And if I go beyond that to the multidimensional structure, now we have discussed about three structures. What are three structures? Hierarchical structure, network structure, and the relational structure. And there's another type of structures we have. We call them as a multidimensional structure. Multidimensional mean we are going beyond the second dimension. If I think about the two dimensions, it's a table. We have X variable and we have Y variable. It's like this. We have this and this, right? We can go down in the table, right? We can go down in the table and we can have some information in this grid, right? We can have, if I take this as the y-axis, if I take this as the x-axis, right? These are two dimensions. The tables are in 2D, right? but it's not limited to a 2D of storing information. Think of Excel sheet. Is it a 2D? Excel sheet, is it a 2D or not?
Yes, today.
It's 2D, but till we are adding more sheets. Once we add sheets, what happened to that 2D structure? Once we are adding sheets, we can add 255 sheets to Excel sheet. Then it become a workbook. Excel workbook is not a 2D. Excel workbook is a 3-dimension. We have another dimension. We can have a Z axis. We can have a Z, where we can have another dimension, something like this, right? Something like this, where we can simply have another dimension. Z is there, right? Likewise here, the multidimensional structure is about cubes. We call them as a cube, like a cube, right? Cubes are very helpful to go for a OLAP. We call it as a online analytical processing. Because why? Once we think of a cube structure, right? Once we think of a cube structure, we can think of something inside this cube. Here, think of this, something inside this. For example, if I think of this as a one surface, this as another surface, there are how many surfaces? You can have 1, 2, 3, 4, 5, 6 surfaces are there, right? So if think of something inside this cube, right? A value inside this cube could have X variable, Y value, and Z value. There are 3 different coordinates could be there. Therefore, online analytical processing is something like we are digging into this information and getting something out, which is going with the data mining concept, right? This is not equivalent to OLTP. What is OLTP?
Online analytical.
What is OLTP? Online. T stand for? What does T stand for? T stand for transaction processing. OLTP. OLTP and OLAP are 2 different things. OLTP is the thing that you do every day in your organization, online transaction processing. In your organization, if you have an information system, every transaction you do, you update your database, and all the things that you do, you are keeping a log from your system. The OLTP are those activities, online transaction processing activities. So every information system that you use in your organization, you are doing what? You are doing OLTP. But OLAP is not equivalent to that. That's why I'm putting equal sign and cut that. It's not equal. OLAP is that you are digging into this sort of a cube and retrieving information based on different conditions, right? It's something like this. Something like this. You could have a multidimensional model where you can have, this might be the sales information, the sales margin is there. You can have a, something like the time period, February and March as the x-axis, y-axis is the sales, and z-axis is the area, sales area. Here, West, San Francisco, Los Angeles, Denver, likewise, these are some of the examples from a foreign country. But you can see that the differences, yeah, you have 2D, you have only the time period and the sales of different products. But if you think of the 3rd dimension, Z side, you can have the West sales in February. You can have actual and budgeted sales in February. If somebody asks Los Angeles actual sales of TV, you can find the information inside this cube. Can you see? Once you think of multidimensional models or cubes, right? The data could be retrieved from different places in this cube. So with the support of OLAP, online analytical processing, what we could do is something like that. So if you are going into data mining, and that's a special course in data mining for those who are doing information system specialization, later on, you will be learning about OLAP and data mining. How can you mine the data with such sort of a cube-like situation? How to retrieve the data, and what are the algorithms available to do that? Right. So this is another model. We call it as the other structure. We call it as the multi-dimensional model. So you can have these sort of different dimensions. Here you can see product type, region, sales channels, and time as one different categories. You can see. Likewise, you can develop such a cubes in different applications are there. Even Excel could be used to develop such a cube in a basic manner. Right? That's a one other area, one other structure, data in the structure. Another structure in the data is object-oriented structure. We discussed about the hierarchical, we discussed about the network, we discussed about the relational structure, and we discussed about the multidimensional structure. And this is the object-oriented structure, right? In this structure, what we do, we mainly concentrate about the object, right? I'm not going to go in deeper, but simple idea is take this example. If I have a bank account as the object, I have different attributes of that object. Bank account, you should be able to maintain custom information, customer's balance, right? For each bank account, the bank account should belong to a customer, right? There should be a balance for that customer account, and there should be an interest allocated to that account, specific account. The account could have different operations could be done. It can operate as deposit the amounts, right? Withdraw the amounts and get owner's information. Likewise, different operations could be done, right? So this we call it as an object in object-oriented discussions, right? That object could have different inheritance, which different sub-objects could be identified here, right? Check-in account object, which have, you can check account, right? Credit line and monthly statement could be operated as a separate information. Right? This might be a savings account object. The account could be a savings account, or it might be a fixed account, or it might be a different type of operations, right? Likewise, this sort of information, if I can have a object, or sometimes people call it as a class like the situation, we can keep this information separately as objects, right? In objects, we have the data and operations into a one specific operation, one specific area, we call it as object. Therefore, I am not going to go in deeper and try to explain the object-oriented structure because it's sometimes it might be too complex for you to understand, but just to have idea that same as other structure, we have the hierarchical, network, relational, multidimensional, object-oriented structure also available with data storing, right? And in object-oriented structure, you have something known as encapsulation as a concept. We should not need to go in deeper, but simple idea is like a capsule. Like a capsule, you have the attributes, you have the operations, everything is controlled by object, and you have them some sub-objects. It's like a father and the son, right? You have some qualities of the father, which in the side of the son even, that we call it as the inheritance, right? Inheritance. We can create a copy of that and maintain that information here, right? This sort of situations are very much useful once you are keeping very huge graphic images or graphic type of a databases, video type of a databases. If you are keeping a database with the video clips or audio segment databases, which always support this supported by this type of object-oriented structure, right? But most of the time, you and we as general public might have used with more with the relational databases because this sort of structures are most of the time joined with the people, those who are doing complex activities with the data, right? For those who are interested, you can later on have some more discussions related to the object-oriented structure. But the idea here is just to introduce the structure, right? And once you think of the structures that we have discussed, this is the evolution of database structures. You can see, right? the hierarchical structure, right, as I told you here, which is work for a structured routine transactions, but cannot handle many-to-many relationships. What do you mean by many-to-many? Many-to-many mean that if I am related with the information and that information in other way around can relate with me, then it will be a one-to-one, right? It's like a one husband and one wife, right? And think of a situation where you can have a structure where you can think of a student and the course. One student can take many courses. One course could be taken by many students. So if I am thinking about such situation, right, a student and course, there might be a student 1, student 2, likewise course 1, course 2, likewise many other different things. This student can take this course, right, as well as this course is another one. This course could have taken by a different type of students or different students. For example, C1 might be taken by this student, C1 course might be taken by this student. Therefore, if we think of student and the course, these two entities having many-to-many relationship, we call it as a many-to-many, right? So many-to-many is a kind of it creates a kind of a complex relationship. What it says that hierarchical type of a structure cannot handle many-to-many relationship. That's a very, very disadvantage once you think of a situation that we are dealing with data. Therefore, because of that reason, hierarchical structure was obsolete. What about the network structure? It's more flexible than hierarchical, but unable to handle ad hoc requests. What do you mean by ad hoc request? Mean that if I am having this sort of a relationship, we know that it's like a mesh like a situation, it's like a network here and there. Relationship go here and there. But assume that if I am deleting something, for example, if I am deleting this, that is my ad hoc request. I am requesting to delete this. If I am deleting this, what happened to this relationship? There's a relationship here, 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 and here. So if I am deleting this, what happened? What happened to this relationship here and here? Likewise, if I am put different requests to the database, if I am doing some insertion, deletion, modification, as such operations, we call them as ad hoc request. We're doing it spontaneously. Then what happened is this structure is not viable for such a changes, quick changes. Therefore, network structure also obsolete now. People are not using because it creates a lot of issues if they want to do some modification to the structure. But relational structure can do both these things. It can handle many-to-many relationships. It can handle ad hoc requests. Because of that reason, relational model is very, very popular among the people, those who are dealing with databases. So I believe that even though you might not had some idea about the databases, now you should have some idea. There is a concept called relational database. Relational database use the concept called set theory. With that set theory, it maintains data in the terms of the tables, right, in the form of a table. And this form of a table is possible to maintain many-to-many relationship. It can insert data, it can retrieve data, or it can withdraw data, or it can delete data, or it can modify data. Likewise, basic operations in the database, insertion, deletion, and modification could be handled with this sort of a table-like situation. We call this table-like environment as relational environment, and for table with the database environment, we call that as a relation, right? We call this table. Another name for table is relation, and we can have different relationships between these tables as we can work with the database, right? So with that, we can have some idea about the structure of the databases, and I believe that you know now by having this idea, by now you should have some idea. We are using relational databases as most convenient way of handling data than in other way. If I am referring to some of the basic data handling, if I am going into some of the complex data handling, we should be able to go for a sometimes a non-relational or object-oriented data structures, but relational are there in most of the places in your organization. Ask from your data expert, ask from your IT department what type of databases you are using. They probably say that they are using relational type of databases, or sometimes they might be saying that they are using non-relational databases, which we're going to discuss later in our discussion, right? Got it? So that's the idea you should have before our break. If you have that idea, we are pretty enough. Pretty enough knowledgeable about the situation, what we need to know by now. After the break, we're going to have more idea about data and data management.
Recording
Right?
stopped.
Anything to know before the break? I'll give a break at this time. It's 9:33. Can we join again to the discussion 5 minutes to 3?
Okay, sir.
Yes. Okay. Then
Okay,
take a break. Take a break and come. And I'll keep the slides still, and meeting will going to be there is the same way. You can have a kind of a refreshment and come back 5 minutes to 3, right?
Okay, sir.
Right. Traditional file processing. Let me.
Recording in progress.
Right. We are in traditional file processing. In the discussion of database management or data management, we need to have some idea about traditional file processing and why people move from this concept to a database concepts, right? Because we know that most of the time nowadays people are using databases. As you might have aware, most of the places we have databases in applications, but usually the applications for application database is not a must. We can have a file separately assigned for a data for application, and we can simply do processing of data without having a database, or manage the data without having a database. In that case, what we do, as the thing that I have explained you earlier, we can easily handle the data with the support of a file. Usually, if I have a data file, or I will say a kind of a file where we can have data in this way, right? And if I have an application or a computer program, or we'll say computer program, right? If I have a program, computer program, written in a way as a user, right? A user can access to a file and get data to a user interface. So usually user what they do, they take the information from a data file. This is the file, right? The user can take application program, use the application program to take the data. What the traditional file processing system is something like this, right? Earlier, before the databases are emerged, or databases are used in application programs, what the people have done, once the computer programming was introduced, right? From the, you might have heard about the different generations of computer program. The computer programs could be to handle files, handle data, where the data is kept in the file format, files, right? So likewise, if I have a file to process, it's like this here, right? You have the program and the file, right? Once you think of the application, the applications are something like this. Applications are used to take the data from the file as well as put the data into the file. Therefore, the processing is happen from the application side, and the user, what the user do, user can use the program to write the data to the file and get the data back from the file and display to the user, right? Here, this explain about such a file processing system, but to have understanding about file processing, I thought that it would be good to show something else. That's why I have this as to explain you the file processing system and compare with this with the database system. Here, the file processing or file-based systems assume that think of a user interface here, and this is the computer application program. Usually, application programs having this information. The application program need to include the file definition. File definition in the sense that the data or the data files that you contain in the hard disk need to be introduced into the application. So that's the file definition mean. So definition is simply should introduce at the beginning of the application program and should write what is the file that you have in this data storage, right? For example, if I have a sales file, right, what is the structure of the sales file, right? Basically, you can say that there will be a say a transaction number or a sales bill number, right? And salesperson information is be there. Likewise, the information in the file or the headers of the file should have to be explained in this file definition, right? Which means if I have a data file, something like this, assume that there are different columns. Yeah. Then each of these columns, this might be a column A, column B, column C. Likewise, the definition is that if I am writing application program, assume this is an application program, a computer program. In the beginning of the computer program, if I draw it here, in the beginning of the computer program, I should have this. I should have this file definition here in the beginning, right? Here in the beginning, I should have the file definition, right? So once I have the file definition, right? This is the file definition. This the file definition in application program. So file definition, you have to write what is A, what is this column, what is the name of the column, what is the structure of the column, structure in the sense that what is the data type that you are having, what is the length of the column, right? Likewise, some information should be there here in the beginning. Without this, you cannot access to this file in this environment, right? Therefore, you have the user is here, you have the application program, you have the data file here. So that structure was there from the beginning of the computer program language use, right? And you have the file handling routine somewhere between this. File handling routine mean that you have to open the file, close the file. Likewise, that information is also there in this application program, right? And data entry and reporting also there in the application program. Likewise, these are the three main important components in a computer program. If it is a computer program written using any programming language, it might be a basic, it might be COBOL, it might be Java, it might be .NET. Likewise, you might be heard of different programming languages. You should have these three components written there with the support of that programming language in traditional file handling, right? So what is happening is in some time back, before the database was emerged, these three things is there. The point is, once we are writing this application, once we have all these things written in programming language, there were some difficulties people face, right? So we'll see that what are those difficulties, and then come back to this and have some understanding about this, right? So once you think of the file handling, this might be somewhat. This is the example given in the book, Dbms book. That's why I just want to give you some equivalent example. And here also, this having a bank account information. If you are doing the file processing, the bank account, checking account processing application, right here. Customer transaction happened here, checking account processing, savings processing, and installment loan processing. Likewise, you have the file storages, and you have the reports that it generated. So for each and every requirement, you have different application programming applications, right? So this is the checking account program, savings account program, installment loan program. Likewise, you have for each and every activity, you have a separate program, same as the program which I have just explained as, right? So if I think of the checking account, I have a separate data for that application. For savings handling, I have a separate data or file for that application. For installment loan, I have a separate file. Likewise, in file processing activities, the program and the file storage has to be there to do the processing. There's no way that we can share the information between applications, right? So let me explain you the problems people face with this environment. These are some of the problems of traditional file processing. And remember that traditional file processing still remain. You can use the traditional file processing. What we try to understand here is instead of traditional file processing, using database concept is more convenient and more effective, right? Now we see what are the difficulties, what are the problems in traditional file processing, which is the process which I have just explained, the use of application program or program to handle, to work with data which is there in a file, right? Data redundancy. You might be heard of this term redundancy. Redundancy is the term of repetitions, right? So every time that we are work with the application, something like this, we might have the same data in the database. For example, if I'm thinking of the checking account application, there might be a custom information you might be keeping there. Savings account file, custom information here also, right? Installment loan file, there might be custom information here also. The same custom information for each of these applications, they have to keep separately. So what will happen is the custom information here, as well as here might have issues of repetitions or data duplications or the redundancy. Same data appear here, here, and here. These three places you might having same information, which we called as the data redundancy. That's the one issue in this environment. Lack of data integration, right? Lack of data integration means that you need a special programs to retrieve data from independent file for ad hoc queries. Mean that if I'm here in this environment, if I'm in the checking account processing activities, if I see that I need to have some information from the savings files, right? Savings files information, I cannot access from here to here. Because why? If I have this application program running here, I might be not having a compatible information in this application. Because these three are three different applications, they are maintaining their own data set. Therefore, if I'm having the same, if I'm having in a single organization these three applications running, one application's data will not compatible with other application data. In some case, they might be using different programming language. They might be using .NET, They might be using Java, right? They might be using COBOL or something. Likewise, different application can use different application program. What they do, they prepare their own application and their compatible file for that application. Therefore, the result is these people cannot access to their file and these people cannot access to these people's file. Likewise, the integration of the file or the information was difficult in this environment. Lack of data integration, right? Lack of data integration. Data dependence. Data dependence mean, as I explained to you, the application program need to specify the format of the file they use. Right? Remember the point that I have explained to you? I explained there, right? Here I explain the way that we can work with the data. Right? Here I explain that way that we can work with the data. I said that if this is the application program, I'm writing application program here, and at the beginning, I need to give file definition. Right? File definition is the structure of this file. Right? The structure of this file. What this means is here you are writing the structure of the file. Structure. What do you mean by the structure? Right? The structure means you have to give the information about the columns. What are the columns? I have 3 columns, right? Column A, column B, column C, or the fields, 3 fields, A, B, C. And what is the data type that I'm going to store here in the data? Whether this is a string, whether this is a character, whether this is a number, whether this is a date, I have to explain. If I have to give all this information about the structure of the file. Assume that I said that my A is a string, my B, my A is the employee number, right? Employee number is A is the employee number. Employee number, I said that 4 characters. I'm giving it this way, 4 characters, right? Employee number. Employee name, I can say I'm putting that within brackets 50 characters can have the employee name, right? Likewise, I can have information about this, right? What the point is here, once I write this, we call this as a hard coding. We write in the program. If I'm using the Java, in the Java programming, I'm using this information, I'm writing this information. I said that this is the employee file, the structure, I writing the structure. Employee number is 4 characters. Employee name is 50 characters. Likewise, I can explain the structure of this table, right? And run the application, right? In running the application, if I'm running an application, I have to convert this application into a binary code. What I do, I am doing something known as compiling or interpreting. After compiling, the file become a exe file, executable file, which I can double click and open, right? So that executable file will be developed after conversion or the translation, and then I can run the application. Fine, no problem. But after identifying an employee which has more than 50 characters as the employee name, what should I do? I should need to change this into, say, assume that 50, there are some people, I say, for the safe side, I change this to 100. I change this to 100. Mean that I have to expand this column into have 100 characters, right? Therefore, if I change the structure of the file, what should I do? I have to change the structure which I have wrote there in my application, which I have hard coded in my application. Every time I am changing this length or the space that I am expanding, what should I do? I should need to change here in my programming language, my program, with the support of in my coding, I have to change. Mean that the thing that I write here always depend on what? Always depend on this structural change. This structure is always depend on this. Which means that if I am doing a change here, I have to do the change in my application program, right? That we called as the program data dependence, right? That process, that problem is there in most of the time while we are working with the file processing approach, right? So if I am doing a traditional data processing, the data dependence is there, mean that application program need to specify the format or the structure in the application program. The program maintenance effort is high. Every time if I'm changing the structure of the file, I have to change the application program, the coding I have to change. Right? We call it as the data dependence. Data dependence. Right? Last one is lack of data integrity or the standardization. Since I'm using different application programs, right? I can have the application program, as I said, that I'm using there is the Java, I'm using .NET, I'm using different other programming language here. Likewise, since I'm using different applications, the standards is difficult to maintain sometimes, right? I might be using because these people are maintaining their own data. They are not really concerned about the others' information. Therefore, they are on their own islands, right? And they might not have idea about others' information, and they might not have idea what are the standards used by other divisions in the same organization even, right? Because of that reason, the lack of data integrity, there's no consistency maintained, and the accuracy of the standardizations might be not there, right? That's why I say the use of homonyms and synonyms, right? You know what is synonym and homonyms? Every time, sometime the one division might be called as a client, another division might be called as the same as the customer, right? Some people call customer as a client, some people call customer as the customer. So in that case, the same person might have two different appearance in the same organization. Likewise, once there is no standard maintained by whole organization, different division even might have different standards, right? So once you think of this sort of a file processing activities, as I told you, the computer application program are always linked with the file, and there is a difficulty of changing the application program and file because this file was developed by the application program, a specific programming language. For example, if this application program written in Java, this will be a Java file, right? If this is written in COBOL, this will be a COBOL file. Likewise, different application programming language will develop their own file with the compatibility only to that application program. Is always problematic, right? With these problems, people have identified these problems. These problems are always make difficulty for the people in the organization because they cannot share the data. They even in the same organization, there are different files which cannot be accessed by other people, right? And there are difficulties in handling the data because sudden change in the structure will always take time to update the files and do that modifications. You cannot quickly ask questions and get the results from application program because of this very rigid structure, right? Therefore, people, those who have experienced this rigid structure, they are searching for a specific mechanism to overcome these barriers, right? So after identifying the concept of databases, people identified that they not need to keep their files separately. They can keep the files, everything together into a one specific place. We call that place as a database, right? Therefore, database approach came after people identifying those problems with file handling approach, traditional file handling approach, which you have just understood. So what is happening in the database approach is that in the database approach, the things that we have wrote here in the application program earlier were removed from the application program. As I told you, I have to write three things in my application program. Any application program I write, I might be writing application program using Java, .NET, COBOL, Fortran, or anything, right? In any application program that we write, we have to write these three things: file definition, file handling routines, and data entry, right? If I'm using Dbms, so database management systems, there's a specific application program, right? Specific program it might be more inward to the system software. The Dbms is a software where it can easily remove these two parts from the application program. Now the application programs only contain data entry and reporting. Now the application program is this. Compare this and this. What's the difference? Right? This is the database system, database approach. Now I have the sales and I have the contract. Two different departments, assume. Right? Don't consider about the name. Just assume that two departments. This department write the application program. Now, not as earlier, I'm writing only data entry and reporting information, right? The Dbms as a software which control definitions and file handling from that point, right? And database is there. Earlier, I had only specific application program and specific file which controlled by this application program only. Now I have many different files. Database is a collection of logical arrangement of data. I have many different files or tables, and Dbms is work as intermediary where I can access to the data files from anywhere in the world or from anywhere in the organization. In other words, with the support of an application program, what the application program writers do, they don't write definitions in the application. They simply access to the database. The database contains the information relevant to the application. Therefore, if I am thinking about the database contains one part of our database. Assume that there's a one part here in the database where it contains data about data. We call it as metadata. Metadata. Metadata is about data about data. What does the data about data mean? Data about data mean about the files that it contains. There might be one file, right? This file might have different information. There might be another table or file. There might be another table or file. Likewise, for about all these files, this place having the information. What is the file? What is the name of the file? Who owns this file? What are the content of the file? What is the structure of the file? Everything contained here in the metadata. Or sometimes we call it as data dictionary. Right? Data dictionary or a metadata. The data dictionary contains this information. Therefore, what the Dbms do, every time programmer write the connection, they can write the connection, they connect to this information, get this data from there, right? Get this definition from there, put here and run the application. The earlier file definition was written there in the program itself as hard-coded. Now, the definitions are not written there. Definitions are there here in this place, in the database, as the metadata. So every time program execute, they take the up-to-date or up-to-second information from here and execute the program. Because of that reason, the updates, everything happen here, will always taken up with this application program with the support of Dbms. The Dbms or database management system is work as a bridge between application program and the database, and Dbms simply maintain this metadata part in the database. Right? The database is not simply a data collection of data, it's a collection of data plus this metadata. Right? Now, shall we go into the place that we have discussed here? Therefore, the foundation of modern methods of managing organizational data is consolidate data records formally in a separate file into a database. So this is the database, and this is the database management system. It's like a bridge between the user and the data, right? and users can easily put inquiry to the database, and Dbms will always get the data and show to the user, right? And there will be a customer transaction processing, check account, savings account, installment account plans. The old application that we have done earlier can have their own application program, and the application program always work on top of this Dbms, right? So in other words, if this is the database, different parties can access to this. For example, this might be a user. This might be a general user, right? This might be a user who might be working with the data, right? This is a general user. General user might be there who can work with the data if they know about the Dbms, if they are giving the information to access, right? Information to access to the database with the support of the DBA. There's a DBA, right? What's a DBA? DBA is the database administrator. DBA, database administrator, who provide authority. He give the username and the password will given to the this information will given to the any user. And these might be written by programmers. There will be another party who can access to the database, programmers. Right? Programmers. The DBA will give these people also username and a password. Right? They write the programs, these type of programs, they write, right? And once they write this program, since the DBA given this information, right? Since the DBA given this username and a password, they can simply access to the database and get the information about the metadata into the application. They are not they are not hard coding the definition. They take the definition from there with the support of username and a password. They can easily link the application program to the database with the username and a password. DBM is allowed to go into the database and get the definition and execute this application. Therefore, these three parties, DBA is the prime, is the control of the database with the support of a DBMS. General users, as you might be the employee in the organization, if you have the access to the DBMS without using the application program, then you can directly access to the database with the support of DBMS interface. The programmer writes the application program and link their program to the database with the support of DBMS. Therefore, the programs used by these people can access to the database through these programs also. Right? So likewise, the DBA will always give this control or the authority to access to this information. He can grant the information or he can revoke the information. Granting means given, revoke means taken back. Right? So DBA can grant or revoke the authority or the access to this database. So DBMS is a software in that case. It creates the interface for data and these parties. Right? That's the structure it happening in this environment. So in this structure, compared to the traditional file processing structure, all these problems were not there. What are the problems that we have understood? We understood data redundancy. Data was repeat. Right now, we have all the data in here in one place. Earlier, we had customer information linked to this file, this application program, customer information to this and customer information this. 3 copies of customer data. Customer files were there in earlier situation, but now I can have 1 copy of the customer data here. All these application programs access to that one single customer file, right? Mean that data duplication or redundancy of data is not there now, right? We have discussed about the data independence or the dependence of the data with the structure. Since I have the metadata here, every time the customer or the programmer not need to write the definitions here. We can access to the definitions from this place, right? Likewise, once you think of the problems that we are identifying here, the data redundancy is not there in the database environment now, right? Data dependency is not there, and lack of data integration, which was happening earlier, was not there. Because why? Now I can access to the any file that I have, which I have given authority as a data administrator, database administrator, giving me the authority. Any file here in this database can be accessed by this programmer or the user if the authority is given by the database administrator, because everything is there here at this place now. Earlier, separate files were there. Now the files, common files are here. This will be shared by many different application programs. Right? Now, what is the database and what is the content of database now? It's a shared collection of logically related data. I used this term earlier even. Logically related. Because why? It should be relate logically, one to another. Right? One to another. It relates in the logical manner where it will be not duplicate. It will be designed in a way where it can relate each other to get the maximum benefit of that relationships, right? And logical related data comprise of entities, attributes, and relationships, right? So we might have, we are not going into that level where we can understand that if I have several information, for example, if I have a, say, if I take this example, if I have the student, early example, right? If I have the student as one entity where I can have student number S1, S2, S3, likewise student number. I can have student name, right? Nimal, Kamal, Aruna, something like this. And if I have course, right? Course information. And if this course information and student information link in this way, I can have one student can have many courses. This is the notation. We call it as a chains notation. I'm using this cross feed, right? One student can have many courses. One course can have taken by many students, right? So if I have this sort of a relationship, right, then course number, I can have course number 1, course number 2, right? This might be MIS, this might be management, GT, C3 might be HR, M, right? Likewise, if I have this information, if I am like to keep some information about the result, right? Result. I can have the result information in middle. I can say student 1, course 1, result is 75. Student 1, course 2, result is 80. Student 2, course 1, result is 50. Likewise, I can have this sort of a relationship. Then these are entities. And if I like to have that information, these are attributes here. Student information, right? Student number is a one attribute, right? Student name is another attribute, which is the features which I can explain about this information. This is the course ID, right? One attribute. Course name, another attribute. Likewise, there are attributes, and the relationship is this here. This is the relationship. I can have many-to-many relationship. Therefore, in order to remove many-to-many relationship, I can introduce this sort of an intermediate thing. Therefore, in case of the database, right? In case of the database, I can have separate student table. This is a student table, right? I can have course table. Course table. This is the student table. This is the course table. I can have the result table. Result table. Likewise, this information could be there here. Therefore, my database comprises of these three tables. This is my database. And student information linked with the result here and here. Right? I have the student number here, course number here. If I like to have more information about the course, what can I do? I can simply link to the course here. I can simply link to there and get more information about what is the course. What is C1? C1 is MIS. If I like to know about the student, I can jump here, this, and get this information. Likewise, I have these relationships in my table. I have these relationships. This is the one relationship. Yeah. One relationship, another relationship. Likewise, I have entities, I have attributes. Now, attributes are, these columns are the attributes, these columns are the attributes. And I have the relationships. Right? Likewise, the database comprises of all these information, plus database also have what you known as catalog or system catalog. This part of the database is a system catalog. This part is metadata or data about data. The database, one part, it having information about the student here. Student information, student table information is there. Structure and everything. Course table information is there. Structure and everything. Special table information is there. The system catalog is that. System catalog is that. So this is the one that is there here in this place. Right? We call that as the metadata. We call that as the metadata, data dictionary, or basically it contains the data. Abstraction concepts are there here in the part of the database. That is the beauty of the data, because that will be creating very easy use of data and manage the database with this data about data or a system catalog or a metadata or a data dictionary part in the database. Right? Almost all the DBMSs which we are using nowadays having those features where we can easily manage this. Right? The data dictionary, this, right? What about this? This is a very unique part in the database where you can easily have these things done. A data dictionary contains data about data, metadata, which is the one that I just explained, and relies on the specialized software component to manage the database in the data definitions. Right? So every time that we are using the DBMS having the features to access to the DBMS data dictionary and handle the data dictionary, which is managed by database administrator mainly. Right? It contains this information. What is there in the database data dictionary? The names and description of all type of data records and their interrelationships. Everything is there. We cannot hide anything from the data dictionary, because data dictionary automatically updated with the support of DBMS every time. The requirements for end users, access and use, the application programs also there, access and use information, who have given the access, who have granted the access, or who have revoked the accesses, right? What objects in the database given the access? Likewise, everything is given there about the access and use and maintenance, right? Everything regarding to the say taking backups, data import, data export, everything is can be handled, and logs and everything maintained there. Since that I talked about the logs, the security will be there maintained. You might be not allowed to access to the same content of the data by two different people. There will be locking mechanisms operate automatically by the DBMS. Sometime back, some DBMS software, related software such as Clipper, we have to lock the files, lock the records, but most of the later DBMSs, something like MySQL, Oracle, SQL Server, all these DBMSs, we are having DBMS inbuilt security features. It protects the database from any sort of violation of rules against the data inside the database, right? The DBMS is a very unique software in that sense, right? DBMS is a very unique software. Where DBMS here, DBMS work on top of the operating system, right? The software system that enable users to create, define, maintain, and use database, and they are provided control access to the database every time the database is created with the support of a DBMS, and managed with the support of a DBMS, and maintained with the support of a DBMS. And application programmers, right? Any type of application program, write application programs with the support of the DBMS, it creates that format, right? Once you are writing the Java application, for example, Java link is there. Every time they can embed the link for the database management system, and DBMS support the Java thereafter to access to the database and get the information and show to the user in the user interface, right? Because of that reason, the databases you create will be named by that DBMS name. That's why, ask from your IT department, they might be say that we are having an Oracle database, or they might be say that they are having a MySQL database. They might be saying that they are having a SQL Server database or DB2 database. Likewise, different database management systems are there, and DBMSs are basically having different categorizations. Very common categorization is single user and multiple user DBMSs. Single user, example for a single user DBMS, anybody? Single user DBMS. A single user can use the DBMS. In Microsoft example, in Microsoft application suite, software suite, we have a single user DBMS. The name of that DBMS? Anybody? I know that some of people might have there who have the idea about DBMS. Just support your friends and give some idea. Single user DBMS produced by or given by Microsoft. Yes, Microsoft Access, you can hear, right? The Coral Paradox is a type of DBMS. Lotus approach, and you can Google. There are hundreds of DBMSs where you can find as single user, and multiple user is another category where multiple users, many users can access to the DBMS, such as Oracle is a very common type of a multiple user DBMSs. We are going for a open source DBMSs. Any open source DBMS that you know? Anybody? Example? Very common open source DBMS. Yeah. Very common open source DBMS, multi-user.
Google?
Google having a DBMSs, but yes, it having a NoSQL DBMS, but relational DBMS. Have you heard of a MySQL? MySQL is a very common relational DBMS. It is a multi-user and open source, right? Google also having different DBMS. You have the Firebase, and a lot of DBMS are there. Likewise, as I told you, I don't need to give example, but there are a lot of example. You can simply Google and take the idea about the DBMS, right? But ask from your organization, IT division, what is the DBMS that you use in your organization? You can get more idea about the DBMS. Here, I have given few examples, but apart from that, you have MySQL, you have SQL Server, which is a DBMS given by SQL, given by Microsoft, as well as you have another common open source DBMS as PostgreSQL, right? Likewise, DBMSs are there where people use for the purpose of managing this process. I believe that you have an idea about Dbms and what is the database and what is the metadata and how these things operate each other with the support of things. And Dbms software, these are some components. If you are familiar with Dbmss, you probably know about these software components. But for those who are not familiar with the Dbms software, these are some common Dbms software components. Right? Just see what are the things that Dbms components could do. Mainly, it creates the database definitions. There's a language and graphical tools to define entities, relationships, integrity constraints, and authorizations rights. Basically, Dbms having the authorities, Dbms having an interface where you can manage the information in different ways. So you know, I have just explained about the entity and how entity interpret in the database as a table, and there are different entities could be converted into a tables, and the relationships could be developed within the Dbms environment. Right? You can maintain the different rules. We call it as a constraints. Right? We can manage the authority of controlling that. That's a definition part of the Dbms in the database environment. And there are non-procedural access. You can have access to the information in the DBM in the database, right? Language and graphical tools to access data without complicated coding. Sometimes you might have a accessing mechanism, something known as SQL or SQL. I should have come to that in the next slide also, right? And there are graphical user interfaces. For example, in Microsoft Access, you have a graphical user interface, and almost all the DBMs now have the graphical user interface. In non-procedural access, non-procedural means that you are not need to give specific process. Only select the thing that you do, then the DBMS will do it for you, right? And application development is there. Most of the DBMS nowadays having application development features. Sometimes development tools are embedded to the DBMS, right? You have the form creation tools, you have the report creation tools, right? All the user interfaces can be developed, very nice user interfaces. Likewise, application development tools are also embedded in the Dbms software nowadays. As well as you have the procedural language interfaces. You can do something like simple programs can be run. Programs in the sense that, for example, if you're having a SQL, structured query language, SQL, is there in DBMSs where you can do programs with the support of SQL, PLSQL, for example, right? And transaction processing, you can mainly say handle the different user activities, sometimes simultaneous user activities, right? You can insert, you can delete data, you can modify data, right? You can say recover lost data after a failure, right? Likewise, all these transactions could be done with the support of a DBMS, and also you can easily improve the performance of the application by doing something known as tuning, right? You can introduce indexes and do some tuning part in databases. Like for DBMS, I know that you need to have a kind of a hands-on experience to go into deeper and have more idea about these components. But just to understand these will be helpful while you are learning about DBMS and while you are working with the DBMS, how to do it in a real organizational activities. We'll see later on. We have a chance with the practical discussions. I'll explain you some of the things related to the basic DBMS components that you have. Right, then database interrogation. This is the one that I was stating earlier. Database interrogation is something like we are working with the data with the support of a structured language called SQL or SQL. Structured is for structured, Q for query, and L for language. Structured query language, SQL, is used for the purpose of handling data or operating data. There are some wizards also there, query wizards, where you can work with the SQL, right? Therefore, basically the database interrogation means you can manage the data by writing queries, you can access to the database, you can insert data to the database, different tables, you can withdraw the data, and you can do some modification to the data, and even can ask ad hoc queries, right? You can take different outcomes from with the support of the data available, right? And basically DBMS, you don't need to have a programming knowledge. Simply drag and drop might be enough, because most of the DBMS nowadays having a graphical user interface, right? The simple questions can ask from the DBMS, and DBMS will take the support of a database and give you the answer in that environment. Therefore, without writing a program, you can specifically access to the DBMS, and through the DBMS, you can take data, filtered data from the given data repository or a database. That is what we call as data interrogation. Before we go into the last steps of the discussion, we need to have some idea about database development. I'm not going to go in deep and explain you each and every step in database development, but give a small idea or a very simple idea with some important places where you might be involved with as a non-IT person, right? So for the IT people, they go through this process, right? But for a non-IT person, you should have some idea at what place you can access, you can give your knowledge to these developers, right? Database development is a cyclical process, same as that you are doing the system development, right? Same aligned with the system development, database also need to be developed in a systematic manner. Otherwise, you might be end up with, as I told you, you might be end up with the chaos, because you might have a lot of data inside to the system, but no use of that data, right? Because it's very difficult to manage data. So every time that you are developing a database, you need to have a plan, right? Plan in the sense you need to have idea what area should I cover. If I am thinking about the whole organization, it will be very difficult. Therefore, you need to divide the whole organization into different parts. Sometimes we can consider from division to division, department. So what data is needed for one specific department? For example, marketing division, right? The enterprise model of business process with documentation. Every time you are keeping documentation, and if you are concentrating about one division, you need to concentrate about the requirement or specification, define information needs of end users in the business process, right? Later on, we're going to discuss about the business process in detail, but simple idea is business process is an activity that we do in organizational activities. Basically, if you are starting the organization in the morning till the closure of the organization, you might be do different business processes, right? We assume that you are dealing with the customer, that is a business process, right? In dealing with the customer, what information you need, we call that as the information need of a customer handling officer, right? Where you might be a customer handling officer in your organization, then the database developers will question you what information you need about the customer. You say that, right, I need the customer number, what the customer name, customer contact number is needed, right? Customer email address is needed. The area or the region that customer belongs to is needed. Likewise, you give some information from your expertise in that process, right? Which is not there in the hands of the developers. Developer not knowing anything but about the technology. So all this business domain information is from you. The requirement specification is very much important for end user information, because you are the end user, developer is the one side. You need to give the information about what information you need once the system was developed by your side, by the expertise that you have. Right? This is the place where you need to involve more in your expertise and give the expertise to the developers. And after a while, you are based on your description, they might be going to the steps of conceptual design. They might be develop it conceptually, right? They develop a kind of a object-based diagram, right? They develop a kind of object-based diagram. We call it as something like ER diagram. ERD will develop here in the conceptual design, right? The design will go into 3 levels: conceptual design, logical design, and physical design, right? Based on your information, they develop a complete TR diagram for the given division, say marketing division, sales and marketing division. You as the customer handling agent, you give the information. Likewise, sales manager might be get interviewed, right? All the other people, sales executives and all the people get interviewed by the developers. They develop their conceptual model, right? That conceptual model they translate into the a logical model, right? And the time of this translation, they can follow any of the structure that we have learned. They can convert that logical model, then they can convert that conceptual model into a relational type of a model, right? They can convert that conceptual model into a hierarchical type of a model, or a network type of a model, or an object-oriented type of a structure, right? Likewise, this logical model designing is based on the path that you are trying to go, right? So here even, we might be not considering about the Dbms, but we have the Dbms in our back of our mind, because why? Every time the logical design need to be developed for a specific type of a structure. That's why here it says logical model, logical data model, or something like relational logical data model, network, hierarchical, multidimensional, object-oriented. Likewise, the logical model is a kind of a model we have a back of our mind, right? I'm going to prepare, I'm going to develop the database which I can use for this purpose. So if I am referring to a relational logical data model, I am referring to a table structures. I am developing a table structure, something like, we call it as a schema. We are using the term schema, right? We are developing a table schema, right? Here we are mainly concentrate about the ERDs, right? Conceptual model, which is conceptual model. Here conceptual model could be a ERP, right? ERD, sorry, it's a ERD. And once you think of logical designing, the relational model might be the result, right? Relational model. Then I am developing schemas for that. Schema. Schema. Yeah, you can see clearly. Right? It's schema. So you can have schema is equal to structure for a relational model. You are creating a table schema, right? Table schema, as well as in the collection of table schema, you can have the database schema, right? Now, once you have these schemas, or the
Excuse me, sir.
structure, yes.
Schema means a set of information, sir.
schema is a kind of a way that we are writing the structure of our table. Sometimes it's like if I am creating a table structure for a customer, I need to write the schema for a given structure. What is the type of the data in the columns and everything.
Okay, sir.
Right? Then if I have a table structure, collection of table structure will be a database structure or a database schema, right? Got it?
Okay, sir.
Right. Then if I have the schema, if I have the structure with me, I can simply go for a physical design. Right? For the physical design, I might be using the Dbms till this point, because I said that conceptual design is a one important point, logical design is the one important point. Both of these points, I not need to basically go for a Dbms. I am not using a Dbms, but Dbms use once I am thinking of the physical design, right? Dbms. So once I am thinking about the Dbms, I can use the Dbms in order to convert physical data model and develop my database at last, right? If I'm developing a database, right, with the support of a Dbms and manage the database with the support of the Dbms, and this is the process which we called as a database development. I have gone through this process very quickly just to give you idea. Therefore, as general users or as users, you might be accessing, you might be giving you expertise, you might be giving you information requirements here, requirement specifications, as well as all these places you can intervene, you can involve with the improvement of the design, and the DBMS once it convert into a tangible format. Here you can work with the people of the developer and see that whether you have the information which you have mentioned here can be accessed through this database, right? This process is a tedious process, though we have gone very quickly. It has to take a lot of time and effort in developing and achieving this level of development of a database, right? And if I here, this is the point that this explain about the planning and other things. I'm not going to go in deeper. A simple idea is the planning is the one that is explained here. Is enterprise model. We need to have a complete model. And as I told you, information needs of the end user is to be understand, right? And identify the key data elements. What are the elements? For example, as I told you, if I am concentrate about the customer, what customer information is needed for me as the customer handling agent, we need to concentrate, right? Then people are going to be interviewed, and all the data collection methods could be used here in getting this information. What are the data collection methods? You should have learned by now about the data collection methods. What ways that we can collect the data?
Questionnaire.
Yes, questionnaire could be used. Any other?
Interviews.
Interviews could be used. Any other?
Case study.
Sorry?
Case studies.
Case studies, yes, you can use the case study because different cases might be discussed. Any more?
Observation.
Observation, good. Observation can be done. Any more? You can do research, right? Different type of places that people have done. What are the key elements that they have used in their databases? So we need those information. Likewise, the research can be done. Research, you can take the different research papers into discussion. Likewise, as you explained that a lot of things are there, a lot of ways that we can take information in the planning process. So once we go into the design, as I told you, conceptual, logical, and physical design. Conceptual design based on the entity relationship diagram. We call this as an object model. We are only check the objects. What are the entities? What are the attributes? Attributes is how you are interpreting, how you are identifying the entities. For example, customer, what features of the customer I am recording in my database? I need the customer gender, customer email address, customer say contact numbers. And sometimes you can question, do I need the customer marital status? Some people said yes or no. Likewise, you can create a kind of an argument within the organization and identifying the attributes where you need to store in your database. It's a very, very important point, because later on, you cannot change these things after you develop. Therefore, this is what you called as object-based data model. Object-based. We are concentrating about the objects. Then comes the logical design. As I told you, here you can create a schema, right? The logical view of the relationship, and you can have the sub-schema even, right? You can have the whole organization into a schema, and different sub-parts could be developed, right? Here we are concentrating about this data, the relationship between data, constraint. What do you mean by constraint? Constraint? Constraints are the rules or the limitations that we have. Sometimes you can say that one constraint could be every table should have a primary key. That primary key cannot be null. What do you mean by null? Null is something like which is not there, which is not zero, which is not space. If the data is unavailable, we say it's a null. Therefore, primary key cannot be space, primary key cannot be zero or null value. That could be a constraint. Or there might be another constraint. For example, assume that we are entering marks to a table of students. We can't have less than 0 marks or more than 100 marks. That's the kind of for databases, different data tables. There might be some constraints. All these things are concentrating in logical design, right? Logical design. It's like a blueprint that you are preparing. It's like a architectural drawing, right? Then the job given to the mason, the physical design. These are the people who do the design with the database management system. With the Dbms, if they have these structures, everything clearly given, Dbms could be used to develop their database, tangible database, right? How data are to be physically stored and access or storage devices, right? Is the design view of the database. Therefore, these three designs are very important. Later on, I'll take these designs again into discussion once I'm discussing about system development. Later in our discussions, in a later discussion, I'm taking back this, then it's better you can remember three of these designs in the database. So this is the logical and physical database view, right? These are the outer side people or the people users here, they access from here, and software interface, right? This is the Dbms. This is the application, because application work on top of the database, and this is the hard side, physical side. Inside the hard disk, you have this data, right? So this logical, software interface, and physical data view are very important to communicate each other in the process of managing data in an organization, right? I'm not going to go into these interactive exercises, but need to have this information about data resource management as a discussion, right? The data resource management. Now you should have some idea about the data. We have discussed about in the beginning basic concepts about the database. What are different terms that we are using, right? After a while, I have explained you what is the traditional file processing and why people move from traditional file processing to the data processing, right? And I just explained you the development of a database, different levels of development, conceptual, logical, and physical. Once I have the data in an organization, we need to manage that resource. That's the one that we are start discussing here. Data resource management, right? Data resource management is a managerial activity. Therefore, it's more relevant to MBA, right? From those points that we have discussed are also important, but this one is more important to MBA because why? You need to understand what you can do with the data, right? So you cannot survive or succeed without quality data, without internal operations and external environment. So no doubt, we have to have that information. We have to have a proper idea about internal activities as well as external environment. Manage data resources to meet the information needs of business stakeholders. What of the stakeholders are there in the business environment? Data resource need to be there where they can take information that they need. Use data management and data warehousing and other information technologies for the purpose of handling this thing. So every time that we are working with different type of databases. Just see a databases that you work in the organization is there in this diagram, right? These are the type of databases you work in the organization. You might be work with the operational databases of your organization. What do you mean by operational databases? Be employee information, it might be any transactional information, everything that we store in organizational day-to-day activities in the operational databases, right? And here you can see that client PC mean that you might be the user, right? And there might be end user databases, right? And the network server mean that through this network you can communicate with many other parties, right? The ones who have collected these operational databases, you might be developing data warehouses. What is a data warehouse? Simple idea. Yeah, simple idea. Data warehouse, by the name implies, it's a warehouse. It's a collection of data. Is this data that you are storing here operational database information you are storing here?
So it's for long-term data storage?
Yes, for long-term purposes, but you are storing here not as it is that we have the information here. You are taking the summary and store there as a data warehouse. Therefore, this is dynamic. What about this? Is this dynamic? Is this changing frequently? This is not changing frequently. This is static, right? This is updated information or summarized information of operational databases are stored in a data warehouse, right? As the name implies, it's a warehouse. We are not putting things to the warehouse if we are every time we are using it. We are putting things into the warehouse to keep it safe for some time period. The data warehouse contain data, a summary of the operational data, which might be kept for a long period of time. 5 years data, you summarize, you compact, and put it into the warehouse. And something known as data mart is a part of the database or warehouse where you can separate for specific requirement. For example, data mart is used for a sales and marketing data mart, right? Employee data mart. So for the specific category of use, you might be creating data marts, a miniature type of a data warehouse, right? And also there might be some external databases also there, right? You might be having the thing that you are accessing in the library, you have external databases. Once you are Google, you are doing external database activities. So all these type of data will be used as data repositories in your organization. We'll see what are these and how we are using these. Operational databases, as I told you, might be named as subject area databases, SADB, or transactional databases, or production databases. And you might have customer, human resource information, inventory databases, all are operational databases. Right? These are different databases which might be having some distributed databases, right? Distributed databases in the sense databases that are copies of or parts of the databases stored in servers at multiple locations. Those who are working in banks, you probably have a distributed databases, right? There are different parts of sections. You might be put it in different places for the sake of safety in one way as well as in the other way to protect the data and keep the data maintenance easier, right? These are advantages. In the distributed databases, you can easily improve the performance of the organization because why you have the data in separate sections stored in different places, then accessing the data and maintaining the data would be easy. What are the advantages? Protection of valuable data. It's like not putting all the eggs in the one basket. If you put all the eggs in the one basket, what happens if basket drops? Everything is vanished. What it happened is you might be remember on the most of the banks. You should know that most of the banks using their distributed databases. Sometime back, once the tsunami hit Sri Lanka, some parts of the country, banks, all the information was washed out. What has happened if since they had some of the sections of the databases stored in different places, there might be some mirror sites or backup sites. They have kept that information safe because of that reason. Likewise, distribution databases are used by most of the huge companies or companies that those who are having maintaining a lot of data for the safety in one side. Right? Data can be distributed into a smaller databases for each location has control of its local data. Right? Sometimes they might be maintaining their local database and globally they can combine everything together if they need in a virtual environment. All locations can access any data anywhere, and main disadvantages is maintains data accuracy is very difficult. If you have a copy of the data, if you have a duplication of data in different places, maintaining the accuracy is very difficult, right? And once it comes into the distributed databases, there are two mechanisms. One is replication, other one is duplication, right? Replicate and duplicate. Can you see the difference, right? The replication, look at each distribution database using a special software application and find the changes, right? So once you are updating the data, if you are using the replication, you might be replicate and the special software need to be there to update all the places that we have. Apply changes to each distribution database and very complex, consume a lot of time and resources because you need to keep that replications every time that it needed. In the duplication, one database is a master, right? You can have a master and the slaves, right? In updating the master database, duplicate the master after hours of all locations. So sometime 12 midnight is the time. There are all the slaves update the master, and master will be updated with all the information, right? The easier to accomplish in some time in that. So likewise, distributed databases are very common. Those who are work in the banks can have more idea. Those who are those who are work in the bank IT divisions will probably know about this area of discussions, distributed databases, right? And external databases.
Excuse me.
Yes.
So, can you go to previous slide? What the disadvantages?
This one.
Yeah, this one. The disadvantage. Why is data accuracy is a disadvantage?
Because why? If you are once you are updating, if you are having a replications, right? If you are having a replications, if you are updating one place, if you are not update about the other place, right? Which is the consistency might be a problem. If you are accessing the one location and if the other location is not updated in that, the accuracy will be a problematic thing, right? Assume that if you are having a mirror sites, right? If you're having a mirror site, one site is there and other side is they are located in two different places. If you are having an update where you need to update both places, right? If you update one place, if you are not update the other place, then if somebody access to the first place might get a one result. If you access to other place might get another result.
Okay, sir.
Right? Therefore, accuracy will be there because it will be always problematic. It going align with the consistency, accuracy, both going hand by hand in that place.
Okay,
Got
thank
it?
you. Okay.
Right. Then I'm in the external databases. External databases, I believe that you are very much familiar because why you are all of you search Google, right? Google, Yahoo are search engines which are using external databases. You are searching for external databases as well as if you are going to the library and you are probably browsing or searching different databases for research, right? Once you are in the final year, you probably go for a research databases. Those are external databases where you can easily, where you have to go for the external parties and get it. Sometimes they are free and sometimes they might have different fee to pay to get that information, right? Because you are registered student in the university. There are some of the research sites, research databases are free to use by yours to you through the say through university IP address from your home place now from the library. Have you checked that?
We don't have that access, sir.
You should have, because I believe that once you are starting the research, now as the new what you call changes in the faculty, now student will be given free access from their home place to the library databases, right? Search for that later, because once you are starting, now you are the second semester, no? Once you come into the third semester or once you start the research, you'll probably given that facility to access to the library databases. Those are external databases where you can search for information. This information might be hypermedia databases. Hypermedia mean that a lot of different type of medias, multimedia, and different medias are available. And there are statistical databases, bibliographic and full text databases are there as external databases, right? That's another area where we people call it. Here, this is the hypermedia databases. Some example. Hypermedia databases contain hyperlink pages of multimedia. If you click somewhere, now most of the web pages are hypermedia facilities there. Once you click, you can run the video, you can listen to some of the music, you can go through some of the explanations. Everything is there now in web pages, embedded to the web pages, right? The interrelated hypermedia pages are there in most of the places. This is an example of such a thing. You have HTML and XML, right? Hypertext markup language and extended markup language will be used to access to image files, video files, audio files, and everything. They are into one place. And what about this? What are the type of database built in early 2000 for the purpose of large-scale databases clustering in cloud and web applications? Anybody having idea? Very lately, people move on to different directions. Sometime back, it's around 10 years back now. They move from row-based databases to the column-based databases. Now, do you have idea? Now I have just explained about the row-based databases, row by row. We are referring to the rows. But if it's a column-based databases, or people call it as the NoSQL or non-relational databases, right? The non-relational databases are these. Some of the example you can think of, right? NoSQL mean not only SQL. It does not mean that there's no structured query language. It's not only SQL databases. You have document databases, graphic databases, key value databases, and wide column stores databases where you can have NoSQL family. Different examples here that you can have something like say all these examples here. MongoDB, for example, is a very common document-based databases. Neo4j, right? And DynamoDB is there is the key value databases, right? Likewise, lot of examples are there. You can search the internet to have more idea. This is the direction where people concentrate of non-relational DBMSs, right? Going from the relational that we have discussed about the tables. No, here in this case, a table convert into the column-based databases, and they are maintaining non-relational DBMS, which is always supportive for a complex type of a databases, right? And finally, the data warehouses. As I told you, data warehouses are the places where you keep the data in a separate purposes, where we can keep off data, static data is used, and most of the time the static data we can convert into a specific directions, subsets of data as data marts, right? We can simply use the data warehouses for analytical processing and data mining purposes, right? And if we think of the data warehouses, this is the kind of a diagrammatic explanation about the data warehouses. Yeah, you have the operational, external databases, data acquired or captured, right? Clean, transform, transport, and load. We use that TL2s, transform, load, and applying activities, right? And data management activities you do, analytical data storages are there, right? And every time that we have to do is through the user interface, you can do the querying and report generation as well as mining the data, right? So we want to think of the mining the data. You have these applications of data marts. You have ERP application, which we are going to discuss later in our discussions, the different chapter. All these data marts, you can have finance, marketing, sales. Likewise, data warehouses could be comprised of these different specific functional related data marts. And you can go into all these different applications: ERP, inventory control, logistics, shipping, purchasing, CRM. CRM stand for customer relationship management, and it basically go into the mining tools, something like this, right? So once you think of the data warehouses, you can have all these pattern identification. As I told you, data mining is a way that we are studying the patterns and identify hidden patterns in the data, which is hidden, which is not clearly identifiable once we check the data, and once we work with the data only, we can identify those patterns. One such application is market basket analysis. You can identify the market basket of a customer and analyze for a long period of time and identify what are the goods going together in one single market basket, right? There will be some examples I'll take you once I'm going into the discussion of CRM late in the discussion. And you can easily use data mining for the root cause analysis, right? Sometimes you might be go for a identification of some manufacturing activities. If there's if you are assume that you are building a nut, that there might be some dimensions in the nut. If the nut is not producing in the same way, you can analyze at what place the nut getting disturbed or getting into a different shape, right? Or root cause of a failure can be identified and prevent customer attrition. If the customer is going to leave the company, right? Customer attrition, you can identify. There are different signals can be taken. If the customer reduce the spending, the customer doing some buying from the organization, the customer gradually reducing the spending with the organization, then you have a kind of alarm that customer going to leave you from leave your organization and going to go to a different organization, right? That we can prevent that if we get that signal earlier. Also acquire new customers. We can identify new customers. There might be some prospective customers who are searching for our product or service in the net. Then we can have some messages, and likewise we can grab their information and contact them early and getting them into our customer base. And cross-selling customers, right? Cross-sell to existing customers. What do you mean by cross-selling? Any idea? Cross-selling? If I am selling a computer and I also can sell a printer also with that. If a person buying a computer might also interested about a printer. That is what we call as cross-selling. And there's something known as upselling also. Right? If you are buying a car, you can add some more value to the car and get the price of the car higher. Something like. So all these things can be done with the data. Right? And also profiling customers with more accuracy. This is a very much common thing that people do now. Make a customer profile, improve the profile. Sometimes your profile might be created somewhere, and most of the time that this is a good business now. Since most of the time people are giving information freely to the outsiders, some of the organization can create the profiles of customers and use that profile to predict the next behavior of the customer. So that's a very good business now, but legally it's protected in some countries. But in Sri Lanka, there might be no such barrier for them. Sometimes we might not aware that some of the people might take our information and create our profile without our knowledge.